Okay, here's a skill, verify inverse functions, that can be kind of tricky. But it is helpful to think about what an inverse is, what two functions being inverses really means. And that just means that if, for example, you have a function f, and you put 2 into that, and then you get 7 out. I'm not saying that's true for this one, by the way, but just as an example. If g is its inverse, then g should undo whatever f did. So if I put 7 into g, it should undo that and send it back to 2, okay? And it should do that for every value that goes into f, right? Anything that you put into f, whatever f does to that number, and it's going to send it somewhere, g sends it back home to where it started. And vice versa, if f is going to undo whatever g does as well. So if we reverse the order, the same is going to be true. That's why one of the ways to test whether a function is inverse, whether two functions are inverses, is if you plug in one of the functions into the other, what should happen is, right, you're plugging x into f, and it's gonna, that's a terrible x. Plugging x into f, it's gonna output f of x, right? And then if you take f of x and stick it into g, it should bring you back home to just plain old x. Okay, so if we compose two inverses, what happens is we just get x, right? We just get the value that we originally plugged into the composition of the two functions. Here's my solution. Whoops, that's not my solution. You got this is for this problem right here. These are my two functions. I just plugged them in, or put them at the top of the page. And in the first instance, what I'm going to do is I'm going to put g of x in, or g into f, right? G of x into f. So right here where there's an x in f, I'm just replacing that with all of g of x. Okay, this whole thing just replaces the x. Okay, and now I go about and see if I can simplify it and see if I get down to x. And sure enough, it does, right? If the -7 and the +7 combine to be 0, so I just have the cube root of x plus 1 cubed. Now the cubing undoes the cube rooting, and I just have x plus 1. That was whatever's underneath the radical. Minus 1 gives me x. Okay. Now that's not enough to show that the two are inverses. I have to also show it works the other way. And it does here. Now what I'm going to do is I'm going to take f of x and I'm going to plug it into g. So wherever there's an x in g, I'm going to take the whole thing of f of x and plug it there. Okay. So this is what -1 and 1 just combine to be 0. And then I'm cube rooting something to the third power. That just gives me the x plus 7 minus 7. The 7's combined and give me 0, and so I just have x. So what I can answer here is that if g goes into f, we just get the resulting function of x, and vice versa is also true. And are the functions inverses? Yes, they are. Okay, so I hope that makes a tricky skill a little easier. Let me know if you have any questions.